In this video, we will discuss about the key scalability and performance optimization techniques used in the system uh, using ASP.NET Core applications running on Azure. We will discuss the architecture's use of caching strategies, database scaling, and message queues. Redis caching is used to store the frequently accessed data, and it's an in-memory data store, thereby reducing the database load and improving the API response times. Data partitioning or sharding is a horizontal scaling technique to handle large data sets, spreading the load across multiple nodes or database servers. And using services like Azure Load Balancer and API Gateway, we can ensure even traffic. Utilizing message queues or Azure service bus, we can decouple heavy operations for better scalability, thereby turning slow synchronous operations or processes into asynchronous uh, background jobs. This slide outlines optimizing the database or the link queue queries. So we can use projections for the EF core, which select to fetch only the required fields where we have complex joins using multiple tables. Pagination is important for large data sets to improve API response time with the deferred execution. For read-heavy queries, we can use Azure tracking to improve EF core performance. And for related entities, we can avoid the N+1 problem with the EF by using eager loading, say include. In general, link queries use deferred execution. It means that the SQL is generated and executed only when the results are iterated over. And indexing database columns used in where or order by clauses is quite vital. And for complex reports or queries, it might be still a better option or a faster option to call well optimized stored procedures. Structured error handling and logging is um something we look at in this slide, and try catch blocks for local exceptions, handling local exceptions, and the global exception middleware can be used for uh, generalized exceptions. And to catch specific exceptions, we can use custom middleware by create or add a custom middleware as well. And structured logging, say using iLogger, we can rather than displaying just plain text, we can log error messages in JSON format, for example, and that can be used for filtering and proper logging. Standardized error responses to API clients is important by sending proper status codes with error messages, improving the reliability and observability in the distributed systems. It's important to manage the memory by using reusing the objects with the help of pooling and reducing the GC pressure instead of creating it every time, and minimizing the heap allocation. Um, and using async and await consistently for all IO bound operations, say the database or the API calls, thereby resulting in non-blocking IO operations. Using async patterns to improve scalability and responsiveness in APIs is important, and also optimizing the EF core queries. Um, for to boost the throughput for CPU, especially for the CPU bound operations, we can use parallel programming. To summarize, we are optimizing the query and caching strategies to achieve scalability and